Yeah, so everybody, thanks for joining us. I am Fred McHugh, the Director of Virtualization Cloud and Automation here at WI, the Services Department. For those of you who joined us last time, this is part 2 in our DevOps for SysOps series, where we're going to build off of what we learned last time with Git. And now, what comes next? Now that we know how to manage our code and where it should stay, Daniel is going to get into some of the particulars of how we now use that. So, all right, I am going to turn over to Daniel, who is going to take it from here.
I don't know how many of you made it to our first part in this series, DevOps for SysOps Part 1. That one was about Git. This one's going to be about CaC, or Configuration as Code for System Admins. So a little bit about me. So I'm a DevOps Solutions Architect here at WEI. I have about 15 years of software developer experience in Kubernetes, DevOps, cloud. I worked at Cisco Foods before this. A lot of people see our trucks on the road, but maybe are not aware that they're a large online retailer, really actually very, very large, and they're a giant in shipping. A lot of software behind that. Then before that, I worked for the Air Force in one of their software factories. And just before the pandemic, I worked at Autodesk for about 6 years. So Autodesk, if you haven't heard about them, they're a Silicon Valley company. They're the giant in architecture, manufacturing, and visual effects. They really got their, it's interesting. They really got their start in being able to help architects design buildings, but now they do so much more than that. And visual effects, they are the top uh, producer of 3D graphics in all the movies that you see. Pretty much nobody competes with them. And across those experiences, I had a lot of international collaboration. I worked with lots of people in Asia, North and South in the Americas, and then all throughout Europe, from the west side of Europe to the east side of Europe. So certifications, got my Azure AI Fundamentals certification when I started here at WEI. In just about a day or two, I expect to get my NVIDIA AI infrastructure certification. So Azure AI cert was really just about the software of AI. The NVIDIA AI one is going to be about the hardware behind all of that that makes it possible. I also have a Security Plus certification, an AWS certification, and after I wrap up my NVIDIA test, I'm going to wrap up my GCP developer test. That's Google Cloud. So our DevOps for SysOps series. This is Configuration as Code for SysOps, or CaC for SysOps. It's our second talk on bringing DevOps practices to SysOps. So just reviewing what these acronyms are. CaC is Configuration as Code. It's the practice of managing, versioning configuration files in a source code repository. Source code repository, that's Git, if you guys recall from our first talk. So the goal is just to treat configuration data as versioned artifacts. Config files that we've had throughout our computer systems for a long time, that's not configuration as code until you get it checked into source code. So you can start versioning it and iterating on it and tracking the changes. So SysOps, system operations. I think of this as the practice of managing computer systems, servers, networks, IT stuff. DevOps, development operations or developer operations. So this is a practice born out of trying to get IT professionals to work very closely with software developers. There was initially this idea of, oh, well, software developers are smart. They can run all these automation tools, right? It'll just be so easy. Except automation begets automation, and these systems just grow and grow and grow. They're very, very powerful and useful, but it's just a lot of work. Maybe at some point 20 years ago, uh, maybe some directors thought, oh, we're just gonna, be able to automate so many jobs away. Uh, Instead, what happened is that they needed to grow their operations, grow their workforce, because there's no way that you can develop an application and develop an internal system that's full of code as well. It's just too daunting. And there's too much tech debt that comes along with managing that automation. So DevOps can be overwhelming. That's the long and short of it. Did you guys see this one in my first presentation? This is a map of all the DevOps tools that are out there, from the CNCF. That's the Cloud Native Computing Foundation. It's meant to be scary. Don't try to read all of these. So don't worry. Part 1 in this series was about Git. Part 2 is just about configuration as code. So what is configuration as code? Like I said before, it's all about just defining your system settings in some kind of a file and then getting it checked into source code. So what kind of tools is that, right? Ansible is a really powerful and popular one. YAML is also really popular. PowerShell, or like I mentioned earlier, it's really just any configuration file, but it has to be checked into source code. Tools like Ansible and PowerShell, they really help you get the automation. They help you orchestrate the automation for all of these configurations. But really, any configuration file that you can check into source code and have ingested by another script, that's the heart and soul of it. So where do you use configuration as code? Well, firewalls, switches, servers, really anywhere where you're managing settings. So it's good for updating hardware or VMs. IAC, infrastructure as code. You might have heard this as well. How is it different? Well, it's really pretty much the same thing. Um, the most popular tool for infrastructure as code is Terraform. And this is really mostly for cloud infrastructure. So infrastructure as code is really just a subset of configuration as code. But because you're provisioning infrastructure, building it from scratch out of the cloud, defining it from scratch out of the cloud, that's really where the name distinction is. So what are some advantages of CaC? Improve consistency and reproducibility. All right, so like I mentioned before, storing your configurations in Git, you'll be able to track them. You'll be able to replicate environments and fix it works on my machine problem, because if somebody says it's not working, don't give them a checklist, right? Just have them run the configuration script on their computer, on their setup, and then you'll know you're using the same configurations. Nothing's missed. If there's a disaster, you can roll back a lot easier and a lot faster too. And it makes tagging easy. So I'll show you an example of how easy it can be. But tagging assets is really important, right? You can't manage what you can't measure. And you need to be able to tag things consistently to know what is what and where is what. Better collaboration and knowledge sharing. So when you're able to check your configurations into source control, you can use all of those benefits of Git, like code reviews, and you can share it with other teams, right? Like the security teams, the developers, and get feedback from them. And if when working with other teams, specifically like security, you can audit those changes, right? If there's a security concern or something goes wrong, um, you know, it really even just in deployments, right? You can say, well, what changed? We didn't see this problem last week. Well, you can go back in time and see what happened recently. So we're also going to increase our automation and efficiency because rather than, since we're not clicking through configuration wizards, we're minimizing those human errors that can be introduced. Uh, because, as I mentioned before, any one of these configurations that you can have ingested by some sort of automation script, well, it's just going to be able to execute that faster, right? Faster, much faster than you can click around. So this is going to allow you to grow and scale. So let's go through some scenarios. SysOps scenario 1. Let's create 3 VMs in AWS. So we'll do it the manual way through the AWS GUI. Pay attention up here in the top right-hand side. I have a click counter. So going through AWS, let's just create some VMs, right? We have to click to EC2, go to launch instance. Let's put in our tags, 1, 2, 3, 4. And now I have to choose the OS, the instance type. We need a key pair so we can SSH to it. Let's configure storage. We'll skip advanced right now. Oh, well, here's some savings here. We can just set the number of instances to 3. Boom. We have 3 VMs. Yeah, that was pretty convenient. Took us 12 clicks, and an experienced IT admin can probably click through that pretty quickly. There they are. 3 VMs, exactly the same. And here's our tags. We got our company, environment, name, owner. It's only 4, but we got them in there. Let's hope we don't forget them the next time we try to create some VMs. So we had 12 clicks on our click counter. So that's 12 clicks per VM configuration because all 3 of those VMs were exactly the same. No difference in environments. So if you want a dev, a test, and a prod, that's a minimum of 36 clicks. Doesn't seem like that much, but there's going to be a scaling issue. And there's no matter how good you are, 36 clicks over and over again every day, you're bound to make some errors. So let's try doing the same thing. Let's launch these VMs with Terraform. All right, so this is our main infrastructure as code tool. So we can define, using Terraform, we can define 3 VMs in just one file. Now, I don't expect you guys to read through all of this code. I hate sharing code in presentations like this. But this is configuration as code, so there's no avoiding it. But I'll highlight what we want to focus on. So we've defined our count, right? 3 VMs, that's what we want, and our instance type. And we can define all of our tags here and merge them in as they get created. So we'll never have to remember to type them in the exact same time every time we create VMs. They're stored in code and they will just automatically get created. So in this example, it really was not a problem for me to say, well, I can do more than 4. I can put in a bunch more tags. And this is especially useful when you have other teams that are not working in your day-to-day operations, but they suddenly want to get an insight on what's running on the cloud infrastructure, right? Maybe you're creating VMs for them, and now they have to manage their inventories as well. So you could have 30 here, and you never have to worry about forgetting anything. It's also really easy to go through the fleet and update them. So yeah, we have our 3 VMs here. Again, though, they're still all the same. So let's create 3 different environments. So it gets a little bit more complicated, but not too bad. Our one EC2 file, it changes a little bit. We now have to introduce a for loop, and we have to introduce a variables file. And this looks a little bit long, but check it out. These are not that different. Each one of these blocks is our environment. Here's our dev environment. Here's our test environment. And here's our prod environment. You may have also noticed that I introduced actually a different instance type into each of these. It's not just a different name. So now we really are creating different environments. And man, that was fast, right? Create 9 VMs right away. Here's our dev. Notice that it's using the T2 micro, prod, the T2 small, and the test instance, the T2 nano. On this um, on this slide, I just wanted to show that when you check your files into Git, you can look at the differences in the changes over time. So using the GitHub UI online, it's easy to see the differences and see all of the changes that were added with the pluses here are highlighted in green. Everything that was removed is in red and has the minus there. So it's just a lot easier to and bit more visually appealing to look at the changes. So uh, that's a big improvement rather than just comparing files side by side. Um, I also think it looks better than doing it on the CLI. So let's review the advantages of Git here. So in using Terraform, did we improve our consistency and reproducibility? Oh yeah. Did we improve our collaboration abilities? Absolutely, because it's in Git. We can share it with other teams. They can tell us what they want for their instances. And did we increase our automation and efficiency? Oh yeah, we didn't have to click through 36 times. So let's go to scenario 2. Let's create 3 VLANs on a switch. And this time, let's not go through the GUI. Let's say that in scenario 2, we're going to create it manually, but let's say that we're an IT professional that is comfortable using the CLI. And so we have our own text file here where we keep our notes. We know everything that we need to do. We don't have it checked into source code, but this is all we need. We just need to SSH to the machine, run configure, set up the VLANs, just run each one of these commands one by one, copy and paste them. So again, I'll set up a click counter, even though it's a copy and paste counter. So we SSH into that machine, into that switch, go into configuration mode, set up the VLANs, 1, 2, 3. Show the VLANs just to make sure we did what we intended to do. Commit our changes. Yeah, didn't seem too bad. It's only 7. But even just one copy paste action is an opportunity for mistakes. I've done it. And sometimes with dire consequences. I thought I was smart and I got into trouble. Especially when working on a large scale enterprise production instance. Yeah, everybody sees your oopsie, even if you can fix it quick. So let's get out of manually copying and pasting. Let's try Ansible. So Ansible is a technology just like Terraform. It basically just allows you to run commands over an SSH shell. So unlike Terraform, which really works mostly in the cloud, Ansible can be operated anywhere that you can start an SSH session on. So we have a configuration file. We don't have to copy and paste, right? This one, it's written in YAML. YAML's, you know, I wouldn't really call it a language. It's more of a style. And I appreciate the style formats because they force me to be clean. So they force you to indent, force you to use dashes and things like that. So again, I don't expect you to, I don't want you to read through all of this. It's annoying to look at big blocks of code on the screen. But I'll highlight that here I've defined my 3 VLANs. And here is a task that I've defined that just says, hey, create a VLAN using those VLAN configurations. Loop through each one of those and create one. So there's only one command to execute on the CLI. This create VLANs.ansible YAML. And with -i, we specify the inventory. Don't worry about that. Inventory is basically just you saying, hey, what hosts do you want to execute it against, right? So we're only targeting one switch here, but you could have an entire fleet of switches. So you run it, see the output of the tasks, it's making some changes, runs the output. And at the bottom, you have your play recap. So it tells you on the left what it executed on. That's the IP address. You can format that to look prettier, but we'll do that. We'll get into the specifics of Ansible in a future lunch and learn. But this is just to highlight that sometimes when you're copy and pasting things in the CLI, it's really annoying when you don't get feedback. Sometimes you copy and paste, you hit return, and it worked, but it doesn't tell you. Ansible tells you. And here's another example of what the config diff will look like if somebody's making a change. So if somebody goes, if you or somebody else goes in and changes the VLANs, you can just look at the commits recently and see, oh, they removed VLAN 20 and VLAN 30. They consolidated them to VLAN 40. So revisiting our advantages of CaC, we definitely improved our consistency and our reproducibility. Remember, I mentioned with this method, you can execute it across an entire fleet of switches. We just showed one, but it really doesn't make a difference if we were going to add 5 more switches, 50 switches, remove 5. It becomes much, much easier to manage a fleet of hardware when you're managing your configurations as code in this manner. Again, we have better collaboration and knowledge sharing because we can show the diffs between changes. And we're posting our configurations for other teams to see on Git. And in the example of being able to scale the number of instances we're running our configuration changes against, yes, obviously we've increased our automation and efficiency, 10x, 100x, 1000x. It just grows as you grow, how much savings you get over doing it manually. So now let's talk about some best practices and what modern development looks like. So number one best practice I could offer for somebody just getting into this is to use an IDE. That's an integrated development environment. So VS Code is my IDE of choice. Uh, Visual Studio Code. VS Code is born out of uh, Visual Studio, which was a Microsoft proprietary uh, software platform that cost a lot of money for companies to buy you a license for. And it was huge. It was like, I don't know, 15 gigabytes or whatever to install, maybe even larger, depending on what language you're developing in. VS Code is um, it's free and it's much smaller. It runs on Mac, Windows, um, and because of things like plugins, you it allows you to just install the bare platform for the IDE and then customize it as you want. Hey, I'm here. I'm highlighting that I can um, enable the plugin features for HashiCorp Terraform. And I don't need everything else, right? I can make it as bare bones or as heavy as I want. And again, it's free. Um, so here's an example of what it looks like if I'm writing some Terraform in the IDE. So it allows me to see all of my files and folder structure on the left. And as I'm typing things out, it'll give me highlights and suggestions on uh, code. It'll give me code suggestions. It will give me formatting suggestions, um, and I can turn those on and off as they're useful or annoying. Um, the next bit of advice I'd give is auto check your code. This is the 21st century, so not everybody has to remember every single uh, formatting syntax. Um, we can use linters to check our formats for us. And we can use plugins, like I mentioned. So a linter versus a plugin. A plugin, as you're typing, it can give you sort of tooltips and highlights and say, hey, I did you mean to do something else? Or it can help you autofill as you're typing things out. So you don't have to type out everything manually. You can use shortcuts and autofill what you're going to be writing. Linters you write, the linters are like small script programs that you run after you've written your code. And it'll just read your file and check it for formatting and give you feedback. I don't know, maybe this one should have been number one. Use Git for all the reasons that we said in part one. But I wanted to highlight something else. Um, this is an example of a code review. So let's say that we have an ambitious developer that wants to sneak in their bad changes. Okay, so here we can see the diff on their change. They wanted to basically just open up everything. But before they can do that, oh, let me move backwards. So when using Git, there's this concept of a main branch. Think about it like production. But when people want to make changes, they have to they have to open their own branches and make their changes there. They can do whatever they want there. It's not in production. It's not going to bother anyone. So if you look at the top here, right where it says open, right? Um, I'm reviewing my own, in this example, forgive me, I'm reviewing my own changes. So uh, a developer wants to merge this commit into the main branch from aptly named sneak bad changes. So when that developer tries to merge those changes into production, the tech leads or colleagues, anyone really that you want to be involved in the code review process will get notified and will actually be required to approve the changes before they can be moved in. So here's an example of what it looks like when I was reviewing my own changes, right? I made a comment on the specific lines. Hey, from port 0 to port 0, this indicates that all ports are allowed, and please narrow your scope. Similarly, right, when I noticed that protocol -1 was being used, hey, this means that all protocols are allowed, and that's not allowed. That's not permitted. So please specify one protocol. So that's the type of comments that you can give on a code review. So after those individual comments line by line, you can write a- an overall comment for the entirety of the review, because there might be 30 lines that need to be changed, right? So you just say, oh, please fix the comments before approval. You submit that review, and there'll be a log of the activity on the code review. There'll be a log of the comments that are made. You can talk back and forth in parallel. I shouldn't say in parallel, I'm missing the word right now, but you and other developers will be able to work independently, leave comments in a forum type of a chat. And ultimately, when everything's fixed, those that are authorized to approve code reviews will approve it, and it can be merged into production. So another bit of advice, best practices, is that in modern development, we don't need to start from scratch anymore. Nobody just opens up a text file and just starts typing away. We can use templates. So Terraform and Ansible, which are, these are tools with the backing of big corporate infrastructure behind them. So Ansible is actually owned by Red Hat now. Terraform is owned by HashiCorp, which is a pretty good sized software company on its own, but is actually in the process, I guess, of being acquired by IBM. Because they have this big corporate backing, they will actually publish their own blessed templates. So you can go to their corporate web pages and get those resources from them. But also you can just go to Git and search in other various places on the internet, because much of the code that you need has already been written and can be reused. If you're using AI tools, those AI tools are really searching the same places that you would search in Google, and it's not bad to ask those AI chatbots very specific questions. But as far as, oh, the large language models are gonna get rid of developers because they're gonna write the code for us. I've been using it for a couple years now, and I have not automated my job away. It definitely helps you search faster, um, and it can definitely give you blocks of code, but not entire scripts. I also wanted to point out that in these two examples, we were working on the CLI. I didn't really show it for Terraform, but for Ansible, you run these scripts off of, right off the CLI. However, if you are not comfortable with the CLI, you don't have to work in the CLI. Again, because HashiCorp and Ansible are backed by big corporations, they built out GUIs for them. And the GUIs don't just help you execute the scripts, they help you orchestrate them and just keep other things they help you keep other things organized. You can organize them into projects. You can organize them into workspaces for different environments. There's a lot of other features that come with those enterprise versions of Terraform or Ansible. It's worth noting that I should mention that Terraform and Ansible are free to use. The GUIs aren't free to use, but you can get into you can download them for use on your computer and run them through the CLI today. So we'll just review a glossary of the definitions of things that we went over. DevOps, right? Development operations or developer operations. This was really about automating software development. Initially the history was, oh, developers can just write code to automate all of the tasks that go into building and releasing software into production and managing their environments. However, they had to pull in IT people because it became the automation begot automation, and it grew and grew and grew and became too much. And so IT professionals, what were called IT admins or SysOps admins, in some companies, they started calling them DevOps engineers as they started writing more and more automation scripts. So SysOps, system operations, these are your IT admins. CaC, configuration as code. Again, the tools for CaC, Ansible, YAML, a config file, as long as it's checked into Git source control. And infrastructure as code, IAC. Again, this is a subset of configuration as code. Really serves the same purpose, except mostly what you're defining is infrastructure, not just settings, right? Not just, again, because IAC, infrastructure as code, is built, is a concept sort of built for the cloud environment. You're not necessarily just executing configurations against a switch. You're defining the virtual switch itself. And IDE, Integrated Development Environment. This is the software platform that allows you to consolidate your tools into one workspace. So Visual Studio Code is what I use today, and it's probably the most popular. If anybody wants me to go into something that maybe was covered into in the first session about Git, I don't have a problem rewinding a bit either. All right, looks like we've got one question. All right, so first question set here says, looks like a big time saver, but as a non-programmer type, it scares me a bit. Yeah, that's understandable. I've heard a lot of people say that they're scared of the programming aspect from it. Well, to that I say, guess what? I majored in marine biology, and just getting into IT systems was scary for me. And then just bit by bit, I just took it one little piece at a time. If you're familiar with, managing any sort of application, maybe maybe you're the system admin for, I don't know, some internal service, right? And something like Jira or something like that, or any of the Atlassian products, or even even if you're a DB admin, actually, especially if you're a DB admin. I mean, come on, the databases in SQL, right? Or any of those others, right? You're writing code if you're writing database scripts. Next question is, have you ever used ChatGPT to write configuration as code? Yes. ChatGPT is not my favorite large language model. I like Perplexity.ai. That's not like a full endorsement. It's just I just find it's better. The thing I really like about perplexity.ai, and that's the website, um, is that it gives citations. So even when it gives me a incomplete or bad code example, I have a link to where it was searching for the answer. So oftentimes that's Stack Overflow, right? So if you do a Google search, you're pretty much going there anyway. But certainly using those GPT services are, I have to admit, it's a lot faster than just searching through Google for code examples. It's a lot faster. Yeah, so I tell people it's a better Google search. It really doesn't write all the code for you. Um, with some things like Terraform, which are like very, very specific and widely used, if you said, "Hey, hey, ChatGPT, give me an example of how to deploy an EC2 instance on AWS," yeah, it could probably give you that block of code without issues. But as I showed you today, that's really just like, I don't know, 5, maybe 10 lines. All right. Thank you, everyone.
Great job. Thanks, everybody.